when you have a population and a sample of that population, you are trying to make a comment about the population. So what you're trying here, you are indirectly estimating a point of population. Simple example, that's what average height of students. For the sample, I will calculate the average height. It is somewhere around 172 centimeters. I am giving a statement, I am giving a hypothesis that the average height of the students, all the students at NIT Trichy could be 172 centimeters. Right? So what I am trying to do, I am trying to estimate a value. I am trying to estimate a value of what is my estimation. What I am trying to do here, I am trying to find out what is the average height of students at NIT Trichy. So full students. But since we cannot find out the height of everyone, we are trying to take a small sample. Based on samples data, we are telling that the average height could be. So I am estimating, I am doing an estimation here. What am I estimating? I am making a kind of probabilistic estimation. I am telling that the average height could be 172 centimeters. So I am trying to estimate a value. For what? I'm trying to estimate a value for the population. So we are making estimations. Okay. So how are you making estimations? So we inference something. Let me introduce the term inference. Right. So based on some observations, you are trying to make a estimation. Based on some observations, you are saying that the average height could be 172 centimeters. Right? So you have to use some statistical techniques here when you want to find out the average height of the population. Since we cannot do, we are going for samples data. Okay, so we are trying to estimate a value. Central limit theorem, it says that in central limit theorem, we are seeing that the mean of sample means. Okay, mean of sample means the mean of the population is approximately equal to the mean of sample means. So if I have 100 points with me in my population, since I cannot calculate average, I am taking a small sample of maybe 7. Sample size is 7. For this 7, I am calculating its mean. I got some maybe around 13 is my sample mean. So I am saying that the mean of this population P could be 13. I am doing an estimation here. Right? I'm doing this estimation. So estimate, we have three terms in this concept of estimation: estimate, estimator, and estimation. So the value which you're trying to find out is called estimate. So population, sample, I want to find out mean. I want to find out what is the mean of the population. Okay. How am I calculating it? Using samples information. For the small sample, you are trying to calculate the mean and you are trying to estimate a value for the mean of population. So value which you are trying to find out. What am I trying to find out in this problem? I am trying to find out the average height of students at NIT Trichy. That is my estimate. So the parameter which you are trying to find out is called estimate. What is an estimator? Estimator is a function which tries to find out. Estimator is a function which tries to find out this value. Okay, it's a method or a technique which helps me in finding out the value for the average height of students at NIT Trichy or the mean of the population data. Estimator is nothing but a method or a function. Maybe you can think central limit theorem is one kind of an estimator. It's a technique, right? Using this technique, using samples information, I am making a comment on the population's information. So what I want to find out? I want to find out mean of the population. How am I finding out? I'm using central limit theorem. So central limit theorem can be called as an estimator. It's a function or a method which helps us in finding out the unknown value of the population. Okay, what is estimation? The process of finding this, the complete procedure, the process of finding the estimate using estimator. Okay, so estimation is nothing but process of finding the estimate, that is the unknown value which I want to find out. Estimate using estimator. Okay, so this is about just little introduction about estimation. Now there are two kinds of estimations. In estimation, we have point estimation and interval estimation. Point estimation and interval estimation. Same example I will take: population, sample. I want to find out mean. I want to find out the mean of this population, which is unknown for me. To find out the mean of this population, I am using samples mean, right? So after applying central limit theorem, I am saying that the mean of the population could be 172 centimeters. The mean of the population could be 172 centimeters. Okay, this is called point estimate. You are giving one point. You are saying exactly the mean of the population is 172. You are giving one point as the answer. You are saying based on the samples information, you are doing some experiments and you are saying that the mean of the population is equal to 172 centimeters. So you are giving one point as the answer here. Okay, that is point estimation. So till now, whatever we have seen, it's all point estimation. What central limit theorem is giving to me is point estimation. Why? It is helping me. It is simply saying that the mean of the population is equal to, approximately equal to, the mean of sample means. So it's a point, directly a value assigned to the mean. Okay, what is the drawback of point estimation? When you make a claim like this, that the average height is 172 centimeters, okay, is it some, maybe if I really find out the population's mean, if I find it as 167, if I find it out as 167, now you see, with my experiments or with my samples information, I made a claim saying that, I made a point estimation saying that the average height of students is 172. But when I really find it out, the average height, it came to be 167. Okay, so your value is not matching here. Okay, we are saying approximately equal, that's fine. But is it exactly equal to that? No, it failed. So what is the chance that your answer is right? Here it is, answer is wrong. You are saying 172. It is not 172. It is 167. Okay. So in this case, you failed. So when you make point estimation, it could be mostly you get no only as the answer. Okay, because it is approximately equal to. And how can we improve? There is one point in central limit theorem. We say the mean is equal to the mean of sample means. When you increase the sample size, when you increase the number of samples, then this value could become closer to this mu. Okay. In central limit theorem, we are taking sample S1 to S10, each of size 5. Okay. You are taking 10 samples. For these 10 samples, you are calculating mean. You got 10 more values here. X1 bar, X2 bar, so on, X10 bar. For this, again, you are calculating another mean, X double bar, right? So it says that when you increase the sample size, there is higher chances that this value could become more closer to the population value. It can become more closer to the population value, right? So this in point estimation, you are making a claim that it is x double bar. What you find out is 172, but the actual value is 167. So it is near only. We agree it is near, but is it really matching? No. So there is a drawback with point estimation. Let's understand what is interval estimation. See, if instead of giving 172, if I could give that the average height of students could be between 165 to 175. This is my claim now. I'm making a hypothesis saying that the average height of students is between 165 and 175. Now you see, what is the actual value? 167. Is it falling in this? Now there is higher chances that the hypothesis you made is true. Whereas in the previous case, your claim was mu is 172. You made this claim. But is it really true? No. Your hypothesis failed here. But in this case, when you give interval estimate, when you do interval estimation, giving no, I hope you understand, giving in the values in interval instead of saying it is 10, say it is between 8 and 12. So there is a high chances that your hypothesis will be valid. So interval estimation is a preferred technique compared to point estimation. Till now, whatever we have seen, we have been talking about point estimation only. Okay. So I think you understood why are we giving the parameters for population. We are giving parameters for the population based on the samples information. When you give them as intervals. Okay. And why it is called confidence interval? Same thing again, 95% confidence level, 97.5% confidence level, level of significance. When you're making a claim, how confident you are about that claim. That's why it's called confidence interval. So the average height, I'm giving the average height as 165 to 175 centimeters, where the actual is 167 or 169, for example. In such case, your hypothesis is very much matching with the claim what you made, right? The actual value is matching with the claim what you made here, right? So this is about confidence interval. So how do we find out this? We have seen point estimations. Till now, whatever we have been studying, we are trying to estimate a value, that is point estimation. So the new term here is interval estimation. So how do we do that interval estimation? There is one technique called bootstrapping. Bootstrapping technique. So we use this bootstrapping technique to give the values in intervals. Maybe say mean you take median, whatever you take. How do you give generally? Generally, suppose there is a population with 100 points. I have 100 data points here. I have a sample with only 12 points. How can we give? Uh, I want to find out again. I want to talk about mean. I want to know the mean of this population, right? So, how do you give an interval values? How can you give generally? What we have seen till now using central limit theorem, you find out sample, you take sample, you calculate its mean, and you say that the sample's mean could be equal to the population's mean. So again, it's a point estimation, right? So let's see what is confidence interval using bootstrapping. Yeah. So empirical bootstrapping technique. How to give values in intervals. Again, we have only sample data, right? In the full story, what we are talking since yesterday, in statistics, we are saying we are playing only with samples data. Since the population data is very large, we take a small sample from it. From that samples data, you find out, you estimate the parameters, and you make a hypothesis on population. You are making a statement on population. Okay. So when you are having a sample with you, yes, we are trying to see how we can give the parameters for population, or how you can make a estimation on population's data in intervals. Let's see this example. So you have a sample, yes. Okay, you try to randomly generate, uh, suppose this size is 20, size of this sample is 20. You try to randomly generate some samples from this again. Okay, this is already a sample. From this sample, you try to randomly generate some more samples. Let them be S1, S2, S3, so on, Sm. From a sample, I am again making some samples. S1, S2, S3, S4, Sm. For each sample, suppose maybe if we are calculating median, we are calculating median. I want to know what is the median of the population's data. I have some data points with me. I have some numbers 1 to 100 or some numbers between 1 to 100 I have in a population. There are 100 numbers. I want to find out median of those particular 100 numbers. Since I cannot find out for those 100 number, I am randomly taking a sample S of size 20. From this sample of size 20, I am taking few more small samples, smaller samples, maybe each of size 3 or 4. Each of size 3 or 4, small size. Let us take 4. So I have drawn few samples. From this already a sample, I am drawing few more samples. For each sample, you find out median. For each sample, you find out the median. So for S2, it is M2, M3, so on, MM. I have got medians now. My goal is to find out, to represent the population parameter in interval form, right? So S1 its median is M1, S2 its median is M2, S3 its median is M3, and so on. I have medians, different medians. Now arrange these medians in increasing order. Arrange these medians in increasing order. So M1, M2, M3, so on, M. Okay, arrange this in increasing order. Assume I have taken 100 samples. M value is 100. If I would have taken 100 samples, if I would have taken 100 samples, so I will have something like this: M1, M2, M3, so on, maybe few more I will mention: M97, M98, M99, M100. So I arrange these means in increasing order. Okay. Now at 95%, I want to give the value. Right? At 95%, I want to give the value. Confidence level. Then from this, if I want to take 95, it is little difficult. Maybe I can take 98. I want to give at 98% confidence level. If I want to take 98 values from this, so I have to ignore this and this. So M22, M99, right? M22, M99 are my 98 values. Okay, therefore, you will say that for a given population, the median will be between M2 and M99. This way you give in intervals. Okay, we will see this once again. We'll try to understand this empirical bootstrapping method. These samples which you are generating from another sample, right? You are having a sample, you are generating few more samples from that given sample. That's why these samples are called bootstrap samples. These are called bootstrap samples. Okay, let's once again see this. What is this interval estimation? How to give this? This maybe we will see for mean, and then we'll go for median. So empirical bootstrapping method. I have a population. I cannot play with that huge data. I want to use a samples data. So I have a sample of size n, small n. From this sample, I will try to generate small samples. Okay, we are trying to generate small samples S1 to Sm. Now for each sample, I am trying to calculate. My task was to find out mean is okay. Mean you can calculate directly. If you want to find out mean, how will you do here? Right? So we will see how to do for, again, this empirical bootstrapping method. This empirical bootstrapping method is mostly used for parameters which are very typical to calculate. This and all are easy to calculate. You know, you have the data points, you can calculate mean. You have the data points, you can calculate the mean of the population or standard deviation, right? Suppose you want to find out the 90th percentile, okay, or you want to find out the median, few typical things which are little difficult to calculate, you can apply empirical bootstrapping method. So here for S1, I'll calculate M1, for this M2, M3, so on, MM. Now you have these different means with you. For each sample, I have calculated different means. Arrange them in increasing order. So M1, maybe M3, maybe M7, something. You have to arrange them in increasing order. Okay. So M100, you have this, right? Uh, to give 95% confidence, we cannot give here because I cannot divide. Let's take, let me write it once again. Sorry. To give at 95%, with this data I cannot do, because 95 means I have to leave 2.5 on the left and 2.5 on the right, which is very difficult for me to leave 2.5 here. Okay, maybe if you consider for larger value like 1000, then you can give. If you say that you have 1000 such samples, so M1, M2, M3, M4, so on, M996, M997, M1000. Now, if you want to give 95%, it is easy to avoid 5 this side, 5 this side, and take that is M6 to M995. This will be my range for mean or median, whatever parameter you are trying to use. Understood? So you have to arrange them in increasing order. From there, you, based on this confidence interval, whatever they are asking, you have to eliminate the values, right? So if it is 99, if they ask 99%, it means 990. If you multiply with 10, so you have to ignore 10 here. So this will be for 99%. This is the confidence interval for 99% confidence level of significance value. For the same thing, if they ask for 95%, so it is 9 into 10, 950. So you have to leave 25 this side and 25 this side. So your range will be 920. Sorry, your confidence will be here, that mean 26th value to mean 976th value or 975th value. This will be your confidence interval, leaving 25 on the left hand side and 25 on the right hand side. The remaining will be your range. Then you will say that I'm 95% confidence that the mean of this particular population can be between this value, or the median of this particular population can be between this value in this interval range. Okay, so this is about estimation. So we have seen what is point estimation. Using central limit theorem, we try to find out always a point. But when you want to give it using in interval estimation, we use it the bootstrapping method. In bootstrapping method, you, from a given sample, you try to generate more number of samples, and then you try to give the no value in a interval range. We have seen how to calculate for mean and median. The same way can be used if you want to find out the values for different parameters, right? Parameters in the sense a generic term for population or a samples data. Parameters can be mean, variance, standard deviation, number of point data points, median, anything. All these are parameters of the population or sample. Generally for population, we try to find out. Okay.